All right, this is the last conic section, hyperbolas. So hyperbolas look like a double parabola. They are mirror images of each other, and we do have two types. We have horizontal and vertical, but we define our parabola by the distance between the two foci. So we have two foci in a hyperbola, and if you're somewhere on either hyperbola, your distance between the two foci, the difference of those two distances is always the same. So let's look at the features of our vertical and horizontal. Again, we have the same features as we did in our ellipse. We have our centers, and then when we have a horizontal parabola, our vertices are along the horizontal as well as our two foci, and then our co-vertices are vertical. And then a vertical hyperbola is the opposite. We still have our center, our vertices and foci are vertical, and our co-vertices are horizontal. Now, a couple new things we have. You see these dashed diagonal lines here? Those are slant asymptotes. That is how we guide the curve, so it's getting really close but never touching. So we have those in both our horizontal and vertical. We also have transverse and conjugate axes. So in a transverse axis, that goes from your two vertices. And then your conjugate axis goes from your two co-vertices. So their locations are flipped depending on your horizontal and vertical hyperbola. So again, your center is the midpoint between the foci. It's also the midpoint between your vertices and your co-vertices. We have those slant asymptotes guiding our curves. Our vertices are A away from the center, co-vertices are B away from the center, and the foci are C away from the center. Then one thing that's different from our ellipse is that C squared is equal to A squared plus B squared, not A squared minus B squared as we saw with our ellipse last time. So let's look at these equations for our vertical and horizontal hyperbolas. They are really, really similar to our ellipse. However, we are subtracting, and whichever goes in front determines whether it's horizontal or vertical. So when X is in the front, it's horizontal. When Y is in the front, it's vertical. And then remember those slant asymptotes, those diagonal lines we talked about? This is how we get the equations of those two asymptotes. So they are perpendicular lines, meaning for one of these lines, you're going to have the positive slope for this equation, and then the other one, you're going to have the negative slope. Okay? So let's graph some hyperbolas. And again, just like last time, I'm not going to work every single one of them because this video will be way too long. So let's start at number 1. X squared is at the front, so this tells me that this is going to be a horizontal hyperbola. And I don't have anything being subtracted from X and Y, so my center is at the origin 0, 0, which I can go ahead and plot. If A squared is 4, that means A is 2. If B squared is 9, that means that B is 3. So I can plot my vertices, 2 to the right and 2 to the left. And my co-vertices, 3 above and 3 below. And so those coordinates are here. Perfect. And then my foci. So if C squared is equal to A squared plus B squared, C squared is going to be equal to 4 plus 9, which is 13. So the square root of 13 is about 3.6. Sorry about that bell. Those foci are going to be 3.6 away from the center. All right, so our asymptotes. Because this is a horizontal hyperbola, that's going to be plus or minus B over A. So I'm going to have one that's plus B over A times X, plus K, but H and K are both 0, so that would be Y equals positive 3 over 2X, and Y is going to be negative 3 over 2X for this one. Now I'm going to show you a trick for graphing your asymptotes. I can make a central rectangle by connecting my vertices and co-vertices. Then if I just connect opposite corner to opposite corner through the center, there are my two asymptotes. Okay. Then I'm going to go for my vertice and curve, getting as close to my asymptote as I can. Again, this is horizontal, so it's opening left and right. And there I have graphed my hyperbola. All right. I'm going to jump ahead to number 4 to do another example. The y is in the front, so this is going to be a vertical hyperbola. Looking at my center, this is the x coordinate, so that's going to be -1, 3. I'm going to plot that. If a squared is 36, that means a is 6. If b squared is 9, that means b is 3. So from my center, a is going to be up 6 and down 6. Excuse me, I have vertices. Up 6, down 6. My co-vertices, to the left 3, to the right 3. So let's get those coordinates written down. Okay. Now for my foci, c squared is equal to a squared plus b squared, which is 45. The square root of 45 is about 6.7, so those are going to be really, really close to my vertices. Oh, and I messed up when putting those coordinates. It's 6.7 above the 3, and then 6.7 below. So that's going to be 9.7 and -3.7. All right. So our asymptotes. This is a vertical hyperbola, so that slope is going to be plus or minus a over b. So that was going to be 6 over 3, so that's going to be 2. So one of these is going to be 2, and one of them is going to be -2. That should be -1. Now it's plus, yeah, we're good. All right, so again, I'm going to draw that central rectangle. And to get my asymptotes, I'm just going to connect opposite corners through the center. And this is a vertical parabola, so it's opening up and down. All right, easy peasy. Let's take a look at writing equations for hyperbolas now. So again, here are for horizontal and vertical asymptotes. We still have our center. We know what A and B are. Let's take a look at when we're given a graph. Let's look at number 1. This parabola is open up and down, which means it's vertical. And then we're given the 2 vertices. Now from my vertices, I can find my center because that's going to be the midpoint. And for this particular hyperbola, the center is going to be at the origin. Then my distance from the center to each vertice tells me A. And it's 1 away, so A is 1 for this hyperbola. Now I need to find B. Well, we're given the outline of our central rectangle, which helps me to identify where my 2 co-vertices are. And if I count, those co-vertices are each 4 away from my center, so that's B. So here's my center, 0, 0, that's H and K. I know A and B. I know it's vertical, so I can plug all that information into my equation for a vertical hyperbola. Let's do that again on number 2. This is a horizontal hyperbola because it's open left and right. And then I'm given my vertices again. So if I look in between, that's going to be my center, and that is at the point 5, -2. And that center is 3 away from each of my vertices, so that means A is 3. Then again, we're given that central rectangle, so I can identify my co-vertices. And if I count, they are 7 away, so that means B is 7. So I know it's horizontal, I know A and B, I know my center, so I'm going to plug that into my horizontal equation. All right, good deal. Now, what if we're not given a picture? Again, I'm going to skip around on these to make sure you see an example of each kind. When you're given your vertices and co-vertices, we can immediately find A and B, and then we can also find our center using the midpoint formula. So what I'm going to do first is use the midpoint formula to find the center with my 2 vertices. And I'm going to find that my center is at 4, 0. Now, looking at my vertices, the x doesn't change, but the y does. So if my vertices are in the vertical direction, that means that this is a vertical hyperbola. And then from 8 to negative 8, those coordinates are 16 apart. Half of that is 8, which means A is 8. Then looking at my co-vertices, y is not changing, but x is. From 1 to 7, those coordinates are 6 apart. Half of that is 3, so B is 3. So here's my center. I know it's vertical. I know A and B. So I'm going to plug that straight in to my equation. All right, let's see a couple more. What happens if we are given the vertices and the foci? Let's look at number 9 here. Number 9. Again, the vertices can help me find A as well as the midpoint. So let's do that. Let's find our center by using our midpoint formula. That's a negative 7. And so my center on number 9 is negative 3, negative 9. Looking at my vertices, the x is what's changing, so this is a horizontal hyperbola. 1 and negative 7 are 8 apart. Half of that is 4, which means A is 4. Now I'm given the foci. The foci are going to help me find C, but I still need B to write my equation. So looking at my foci, y is not changing, but the x values are 10 apart. Half of that is 5, which means C is 5. So I'm going to have to use that C squared is equal to A squared plus B squared relationship to find B. So 25 is equal to 16 plus B squared, which leaves me with B squared being equal to 9, which means B is 3. So here's A, here's B, here's my center. I know it's a horizontal hyperbola. So x plus 3 squared over 16 minus y plus 9 squared over 9 is equal to 1. Okay. And then the last type I'm going to show you is number 11. This is when we're given the co-vertices and the foci. So the co-vertices are going to help me find my midpoint as well as B. So let's look for that center, our midpoint. And I am getting negative 1, negative 3 for this one. That's my center. Now my co-vertices. The x value is changing, but those are my co-vertices, which means my vertices are going to be vertical. So this is a vertical hyperbola. And then this 5 to negative 7, those are 12 apart, and half of that is 6, so that means B is 6. And again, the foci are going to help me find C, but I still need A to write that equation, so let's look at our foci. X isn't changing. The y values, however, are 20 apart. Half of that is 10, which means C is 10. So again, C squared is equal to A squared plus B squared. So we end up with A squared being equal to 64, which means A is 8. So here's A, oops, here's B, here's my center. I know it's a vertical hyperbola. So y plus 3 squared over 64 minus x plus 1 squared over 36 is equal to 1. And that will wrap it up for our hyperbola notes. And we just have one more day of conics, just putting it all together, and we will be ready to test.